Alright, so here goes. Differentiation. Two rules. All about the power. So, first thing, we're going to take this power of 3, bring it down to the front, and use it to multiply everything else. So we have 3 times 5, and then for the x, we're going to reduce that power by 3. So it's going to be 3 minus 1. When we expand that, 3 times 5 is 15, and 3 minus 1 is going to be 2, so it's going to be 3x squared. 15x squared, sorry, right? Yeah, so that's it for that one. Right? For this next one, same principle. The power is 5, so we bring 5 to the front, and we use it to multiply by everything else. So in brackets we have 3 so it's 3x to the power of 5 minus 1. Subtract 1 from the power. Right? And that gives us 15. So it's 15x to the power 4. Right? So 5 multiplied by 3, 15. Subtract 1 from the power, we have 4. Right? Really not bad. Here, y equals 8x to the 5th power. We're going to say dy over dx is equal to, so again, bring the power down, 5. And we're going to use that power to multiply by everything else. So in the bracket we have 8. So it's 8x to the power 5 minus 1. That gives us 5 times 8, 40. And it's x to the power 4. Alright? Pushing right along. If we have 5x, because x is to the first power here, it's a straight line. So for straight lines, they have a fixed gradient. So it's just going to be 5. Alright, we did this in class and we explained the rationale. Alright, but you can work it out a long way. You could say the power is 1. Alright, so you could say the power is 1, bring the 1 down, use it to multiply everything else. So we have 5x to the power 1 minus 1 equals 5x. So it's 5x to the power 0. Now anything to the power 0 is 1. So it's 5 times 1 equals 5. So we didn't have to go through all of that because it's a straight line, y equals 5x. We know it's just 5. Right? That's cool. So if we had y equals 155x, then we could have said dy over dx. Right? When we differentiate y with respect to x, we would simply get 155. No long working. How about this? Here, there's no x, there's nothing to differentiate, so it would be 0. But for persons who like to do things the hard way, would recognize that y equals 5 is the same as y equal 5 x to the power 0, because x to the 0 is 1. So we'll bring down that power 0 and use it to multiply by everything else. So in brackets we have 5 x to the power 0 minus 1. However, it doesn't matter to what everything in the bracket works out to, because if you multiply by 0, you get 0. Right? So, very simple. So it doesn't matter the number. If we have y equals 555, then dy over dx is simply equal to 0, no longer working. There's no x to differentiate, so it's just 0. Alright, continuing. Alright, so how about this one? We do them one by one. So, should be able to see the pattern now. So, x squared, bring down the power, it's going to be 2x to the power 1. Plus, for 7x, it's just going to be 7. And for the minus 5, that's going to be 0. So we don't have to represent that. We can leave that out. Alright, so that's it. That's it. Alright, x squared becomes 2x. 7x becomes 7. And negative 5 becomes 0. How about this one? Alright, so here we have, the first thing that we have to do is deal with the cube root of x. Right, and from the laws of logarithms, we should remember that cube root of x is the same as x to the power 1/3. Right, x to the power 1/3. Same thing. Right, so now if we're doing this, then we would write this expression as y is equal to 7 x to the power 1/3, to the power negative 2, sorry, plus x to the power 1/3. Right, once we have that, we can now say dy over dx is equal to, and we do them one by one. So for the first one, we will have negative 2 right? Then we have 7 x to the negative 2 minus 1 is negative 3. Plus 1/3 times x to the 1/3 minus 1. And we should now see that that is negative 2 times 7, that's negative 14. X to the negative 3 plus 1/3 x to the negative 2/3. Now, if we are going to rearrange these, right, to show the cube root notation, and get rid of the whole negative sign in the power, just remember that let's write it. X to the negative 1 is the same as 1 over x. X to the negative 5 is the same as 1 over x to the 5th power. So this would give us so for the first one, it will be negative 14 over x to the 3rd power plus 1 over 3. In the denominator now, we would now have x to the positive 2/3. Then we can go a step further. Negative 14 over it's going to be x to the 3rd power plus 1 over 3. And we can put that now using the symbols. So instead of writing 2 over 3, we can write the cube root. So we would put the 3rd root of x squared. Yep, and that would be the other way of writing that answer. Alright, so let's look at another. 1 over x cubed minus 1 over the square root of x. Alright, so let's write them in the format x to the power. So 1 over x cubed is the same as x to the power negative 3. Alright, minus 1 over x to the half is the same as x to the power negative a half. Alright, and for those who are not seeing that step, let me just put it in. So that's how we get here. Alright, 1 over x cubed is the same as x to the negative 3. 1 over square root of x is the same as 1 over x to the power half, which is the same as x to the negative a half. So now that we have this, we can solve it by saying, so the first derivative of x is equal to, so we're going to have negative 3 times x to the power negative 3 minus 1 is negative 4 minus, then we're going to bring down negative a half. Alright, times x to the negative a half minus 1, which is negative 3 over 2. Of course, that's going to be plus, so it's going to be equals negative 3 x to the negative 4 plus half x to the negative 3 over 2. Alright, but we're not done. We want to get rid of those negatives. So we're going to say, one step at a time, we're going to have negative 3 over x to the positive 4 plus a half, and in the denominator we're going to have x to the power positive 3 over 2. Still not done. So that's going to be equal negative 3 over x to the 4th plus a half, and in the denominator, instead of writing x to the 3 over 2, instead of writing over 2, we're going to write the square root. So it's going to be square root of x to the power 3. And that would be the end of that one. Right, so remember what we have here is a correct answer. Right, so this is a correct answer, but for the multiple choice, you can see the answer in other formats, which is how I normally put it. Right, so you should be comfortable making that conversion. All right, let's do a few more. All right, for this one, right, there's what we call the quotient rule, how to do differentiation when you have divisions, but we're not going into the quotient rule. So all we want to do is recognize that everything at the top is being divided by x squared. So if we see that, then we should know one by one. 5x cubed divided by x squared leaves 5x plus 7x squared divided by x squared leaves just 7. And then minus 9 over x squared and we can now simplify this. 5x plus 7 minus 9 x to the power negative 2. So we now have something that we can differentiate in an easy way. No divisions to deal with. Alright, so f derivative of x is equal to, for the 5x, we're just going to have 5. For the 7, that's going to be 0. And then for the other one now, bring down the minus 2. Right, so we have minus 2 times minus 9 to the power minus 2 minus 1, that's negative 3. Alright, so that's going to give you 5 plus 2 times, the 0 is gone, so 2 times 2, 2 times 9, 18, x to the power negative 3. And we can take care of that negative 3 by saying equal 5 plus 18 over x to the positive 3. Yeah, that takes care of that. Alright, nothing difficult in differentiation. Alright, this one, very simple. So y is 5x squared plus 3x minus 4. So we want dy over dx, which will be 2 times 5, 10, x, plus, for the 3x it just becomes 3, and the negative 4 becomes 0, so we don't have to acknowledge it. We can leave it. Alright, so that one is finished. How about this one? So we have dy over dx equals 2 times 5, that's going to be 10x, minus 4 will be 0, so we can ignore that, and then 60x becomes 60. And that's all there is to this one. Alright, one more. 1 over 3 x to the power 3. We know the first thing is we need to have x at the top instead of in the denominator. So this is going to be 1/3 x to the power what? -3. And that's it. So we will now say the derivative of x is equal to -3, and I'm going to put, since it's a fraction, I'm going to put -3 over 1 times 1/3, ouch, times 1/3 x to the power -4. -3 minus 1, -4. And now we see what? 3 cancels 3. So we're left with just -x to the -4. We want to simplify, so we want to have -1 over x to the +4. And that is the complete answer for this one. All right, we're pushing through a lot of examples to make sure you're comfortable. This one. How do we take care of the root? We put it as a denominator in the power. So this is going to be x to the power 2 over 3. Yeah. So we have that now. We're simply saying the derivative of x is equal to, bring down the 2/3, times x to the power 2/3 minus 1 will be -1 over 3. That's negative. Alright, so 2/3 x to the -1 over 3. Simplified, we have 2/3, and denominator, we have x to the power +1 over 3. And because it's 1 over 3, we can go further. So 2 over, so it's 3, but the 1 over 3 is the same as the cube root. So we have cube root, and it's just x in this case. And that's our answer. So 2 over 3 times the cube root of x. Also, we have to know our special cases. Right, when we differentiate e over x, we simply get e over x. If we differentiate ln x, we get 1 over x. Right, so those are our special cases. Right, so we won't be doing, chain rule. Yeah, we're doing chain rule. We won't be doing quotient rule or product rule. But we're doing the chain rule. So for the chain rule, all we want to know is that we see it as a function in a function. Right, so ax to the n plus b, all of that is being raised to the power b. So it's a function within a function. Right, so what we do is we differentiate the outer function. So we bring down the m times what's in bracket raised to the power n minus 1. But then we have to differentiate in a function as well. So let me show you. So here we have it. So we're going to say dy dx is equal to, so outer function. So we differentiate the big function. So I bring down the 3. back our bracket. So in brackets we have 5 x squared plus 6. And the power becomes, hold on, let me just do that again, just to show it properly. Right, so 5 x squared plus 6. And the power becomes 3 minus 1, which is 2. So that's it, the big function, the outer function. But we're not finished, because we now want to multiply all of that by what's the differential of the internal function. So for the internal function, it's just 5x squared plus 6. So we differentiate 5x squared, we get what? 10x. Differentiate 6. It's just 6, so we get 0. So this is what we get from that. Alright, so we multiply the two. So 10x times 3, that will be 30x times 5x squared plus 6, and all of that to the power 2. Alright, so remember we did to differentiate the big function, leave everything in the bracket as it is to differentiate the big function. Then we multiply all of that by what we get from differentiating the internal function. Alright, so let's try one more. Let's look at this one. So we're going to say dy over dx is equal to, so bring down the 2, that's the first thing. We're differentiating the big function. So everything in the bracket stays the same, 4 x cubed plus 5x. And then the power is now 2 minus 1, which is 1. And we're going to multiply all of that by what we get from differentiating the internal function. So we're going to have differentiate 4x cubed, we get 12x squared, plus differentiate 5x, we get 5. So this will be the end result of that. Except that this one can now be simplified a lot more. Right? Because what we really have is this. 2 times 4x cubed plus 5x times 12x squared plus 5. Alright, so this is what we really have now. And technically this can be expanded. Alright, so we're doing a multiplication. So it's 2 times the first term times the second term. So let's do the first expansion. So 2 times 4, that's 8, times 2 times 5 is 10. Alright, so that's 2 times the first term. Then we have 2 brackets being multiplied. I will know everything in the first bracket multiplied by everything in the second bracket. All right, so let's go. All right, so 8x cubed times 12x squared. 8 times 12, that's what, 96. And it's x cubed times right, it's x cubed times x squared, so that's x to the 5th. Plus 8x cubed times 5, that's going to be 40x cubed. So that's 8x cubed times both terms. Then we have plus 10x times each of the terms. So 10x times 12x squared, that's going to be 120x to the power 3. Plus 10x times 5 will be 50x. And here you notice the terms in the middle are both x cubed, so we can add them. We have equal 96 x to the 5th power plus 40 and 120, that's 160 x cubed, and all of that plus 50x. Right, so this chain rule example a little bit longer than the other one, but just step by step. Alright, so here we continue with our special cases, right? For our special cases, if you differentiate e to the x, you get back e to the x. So let's look at the chain rule now with the special cases. So here the special case is that we have e raised to the power 2x. So it's being raised to a function 2x. So we have the small function 2x within the big function e to the 2x. So the first step is differentiate the big function e to the 2x. So we have dy over dx is equal to, when we differentiate the big function, we get back what was there, e to the 2x. Right, because when I differentiate e to the x, you get back e to the x. So the big function e to the 2x, you just get back e to the 2x. But it's not done because we also have to differentiate the small function, which is 2x. And when I differentiate 2x, you end up with 2. So the answer is 2e to the 2x. All right, let's try another one like that. So I'm going to e to the 3x. So the first thing is differentiate the big function, e to the 3x. We get back exactly what was there before, e to the 3x. Differentiate the small function, 3x, we get 3. Answer, 3 times e to the 3x. So you should see a pattern. If it was e to the 4x, dy over dx would have been 4e to the 4x, and so forth and so forth. Right, so that's a chain rule with the special case e to the x. How about the other special case? The other special case is, if you differentiate ln x, you get 1 over x. Right, but here we have ln not just x, we have ln of 2x. So we have our chain rule, function in a function. So the first thing is, we differentiate the big function. Alright, so we differentiate the big function, ln 2x. So if I differentiate ln x, we get 1 over x. So if we differentiate ln 2x, the big function, we're going to get 1 over 2x. But we're not finished, because we also have to differentiate the small function, 2x. If you differentiate 2x, you get 2. Because we have a fraction, I'm going to put 2 over 1. Now right here, you should see something. You should see that 2 here will cancel 2 here. And what does that leave us with? 1 over x. Alright? So for the chain rule here, even though it's ln 2x, we still get back 1 over x. How about if it was ln 5x? So we differentiate the big function and we get 1 over 5x. But we're not done, because we have to multiply by what we get when we differentiate 5x. We get 5. And 5 cancels 5, leaving us with 1 over x. Alright, so basic principle, differentiate the big function, the outer one, then differentiate the smaller one. And when you differentiate the big function, you keep what's here as is. So it's 5x, so it's 1 over 5x. Alright. Turning points, just note that the gradient of a firm of an equation is where the turning points are equal to where the gradient is 0. The turning point is where the gradient is 0. Right, just like we did earlier. So if we differentiate this function, we get dy over dx is equal to, so x cubed, that becomes 3x squared. Yeah, so we have 3 times that. So 3 times x squared, and that's divided by 3. Alright, if we do it the long way, you'll be saying I'm going to put 3 over 1 since it's a fraction. So bring down the 3 times and the power 3 minus 1, 2, so x squared over 3. Then we have minus 25. Alright, so 3 cancels 3, gives us x squared minus 25. So remember, the turning points are where the gradient is 0. So for the turning points, we're going to set x squared minus 25 equals 0. And we can solve this 2 ways. Alright, so let me do it 2 ways. Alright, so we could say bring over the 25 and say x squared is equal to 25 means x will be equal to the square root. Remember that every quadratic equation has two solutions, so it's not just 5, it is going to be plus or minus 5, which means positive 5 or negative 5. Right, so that's 1. So the turning points will be x equal plus 5 or x equal negative 5. The other way to do it would be to factorize. Right, so x squared minus 25 equals 0. Therefore, difference of two squares. So you're going to say x plus 5, x minus 5 equals 0. Continue that, we get x plus 5 equals 0, or x minus 5 equals 0, which gives us x equal negative 5 or x equal positive 5. Same answer. That's either way works. Alright, so finding the turning point is just finding the gradient and set the gradient equal to 0 to solve. Alright, so that's basically it. Wishing you all the best. Take care. Practice, practice, practice.